Welcome back. This latest series of SteelCasts has very much been focused on the challenges around decarbonising the steel industry. And throughout the series we've tried to take a holistic approach to the issue, talking not just about the technological challenges, but also the economic, environmental, political and market challenges. Now, for those of you who have listened to the last 20 or so episodes, I hope, like me, that you've learned something along the way. But I also suspect you'll have come to some conclusions already. Firstly, this topic is a whole lot more complex than it might appear at first sight. There is no silver bullet. And secondly, success, however that might be defined, will only come from a genuine, open and proactive collaboration between governments, businesses, academia and supply chains. And thirdly, while energy-intensive industries such as steel may look inward for solutions and look for governments to support technology change and energy parity, every single market sector is grappling with its own issues and pushing forward the boundaries of new technologies and new ways of working. And maybe in no sector is that more true than in the construction sector. Buildings such as those behind me today, the Active Office and Active Classroom here on Swansea University's Bay campus, which are completely off the grid, are breaking the mould in terms of what is possible. Buildings as power stations, they call them here, which provide huge opportunities, especially, for example, in social housing. We'll put the link to the Active Classroom in the podcast notes. And for those of you watching this pod on YouTube, while you can see the beautiful colour coat steel cladding, what you can't see is so many of the amazing technologies used within the buildings that are based on steel solutions. Today's podcast is another insight into the solution end of the construction supply chain and another example of a project that is heavily predicated on steel as a material and the expertise of Tata Steel as a supply chain partner. The podcast comes again from the Building Research Establishment in Watford, where we caught up with Alex Small, Tata Steel's Market and Business Development Manager. He talks to us about an amazing building called the SEISMIC demonstrator building, again using modern methods of construction and again heavily predicated on steel solutions. But don't let me try to explain it all. Here's Alex. So today we're talking construction, and we're here in Watford with the SEISMIC demonstrator building, and I'm delighted to be joined by Alex Small. Alex is the digital platform and innovation lead for Tata Steel, and Alex, brilliant, thanks for welcoming us here. What a place. I mean, it looks even better on the outside than it does on the inside, to be honest, but we're here today not to talk about what the place looks like, although it looks fantastic, but more about the technology behind it, how it fits in with the legislation that's moving forward on construction, and saving energy, and there's a whole load of things to talk about, aren't there? Where did SEISMIC all start?
Well, it started actually from one person in particular who's working at the Department for Education. There was some frustration from his side that more modular manufacturers weren't being used by local councils and regions to build more schools. Obviously, a school has very set spaces in terms of dimensions for classrooms, toilet blocks, halls, etc. So it very much fits a modular design. And when asking the right questions to the right people, it actually turned out that it was too high a risk quite often for them to use modular manufacturers for multiple schools, simply because all of them used slightly different section sizes for their steel components and the frames of those modules. And therefore, if one of them was to go under or wasn't able to complete a project, it's very difficult for another one to come in or a main contractor to come in and complete that building. Whereas if you have a standardized system, a standardized set of components, a kit of parts approach, if you like, it's much easier for someone else to come in and finish that building off or to collaborate on projects.
Yeah, and standardization is key to this, I understand that. But if we go back a step, this whole concept of modular building rather than traditional build, what's the advantage of that, and why is it so good for places like schools and hospitals?
Well, there's a terminology that came out of actually a report a few years ago called Modernise and Die by a chap called Mark Farmer from Cast Consultants, and what he focused on is something called pre-manufactured value, and this is all about how much of the construction project can be completed off-site, away from inconveniencing people, away from the dirt and the dust, and inside factory conditions, better quality of or better conditions for working for people, more reliable, higher quality control. If you can put most of your as much of that finishing of a building into those factory conditions and then bring it to site as pre-assembled, fully finished or partially finished assemblies and build a building almost like Lego bricks, then you can drive significant saving of time on site, where any contractor will tell you that's where a lot of the cost goes. You save a lot in health and safety as well, and the end quality of the product normally is significantly improved.
Yeah, so when you describe SEISMIC, I'm quite surprised the size of the place apart from anything else, but when you describe SEISMIC, would you say that it's the technology of using steel frames, or is it the system of standardisation, or is it a sort of a supply chain collaboration project? How would you describe it?
SEISMIC has been described as the Henry Ford moment for construction, because it's a little bit of both. It is a system that requires steel, in that modules are mostly, majority of modules are steel frame. So the core of the chassis, if you give that automotive approach, is a steel frame. And then you can bolt on and fasten on the wall systems, the windows, the doors, the flooring systems, the ceiling, the roofs. Everything else can be fixed onto that. Meaning that you can almost turn that sort of modular construction process into an assembly line. And what we want to do as Tata Steel is move downstream and play more of that sort of automotive tier one style supplier into the construction sector. So we would make those floor cassettes, we would make potentially those ceiling cassettes and those wall systems and supply them just in time into modular manufacturers or directly potentially to site for main contractors to then assemble those and build a module, build a frame, send it down the assembly line, and more gets added to it until you have something that can be delivered and bolted on site. So we can potentially play a major role in the automation of a supply of a flow line, effectively, for buildings, which is quite exciting.
And it is an interesting comparison with the automotive industry, and people will well know about common platforms for different models of car and even different brands of car. And I remember talking to Matthew Teague about the same thing. But as a steel company, so people say Tata Steel, we just make steel. You don't make buildings. Are we? Although we do starting to make things, panels and profiles and sandwich sheets and so forth. But are we moving down the sort of supply chain into more construction where there might be more value?
We are. We would like to. The challenge is, if you have a system like SEISMIC, where you've got standardised components, kit of parts approach, if we aren't involved in the assembly of the systems and the components, then we aren't necessarily the ones that the components get bought from. Whereas if we have that through a supply chain approach, then we can make sure that the components, the steel components that go in the frame, in the floors, in the ceilings, in the roof cassettes here as well, and those wall systems and the cladding systems, whatever's involved in that collection of assembly parts and systems, have steel that's come from Port Talbot, that they go through potentially the colour coat line in Shotton, assembled into systems, pulling channels through from other parts of the business, and then we assemble them, more added value, with a great focus we have on quality control, tolerance. We are a very trusted supplier already, just our brand, our reputation, meaning that we can really play an added value role, and we get the value. So not only are we locking in components, locking in Port Talbot steel, but we're getting the added value of being a downstream supplier.
Yeah, and people would be wrong to imagine that SEISMIC, it's called a demonstrator for a reason. They'd be wrong to think that SEISMIC is just about the frame. You were showing me earlier some of the fast fit systems and some other systems upstairs. There's a lot of technology that we have brought to the party, I guess, as Tata Steel.
We have, yeah. Actually, what's really interesting about this platform this project is it was a demonstrator project, and that meant that after the 18 months of the funded project from UKRI, we had to have a building, this demonstrator building, where a member of the government could come and literally cut a bow on the front of the building. So what we actually did in order to de-risk that for the project, this isn't an R&D project. This wasn't an R&D project. We needed something commercially viable. So we couldn't go off and just start from scratch. How are we going to make a ceiling cassette? How are we going to make a roof cassette? So we actually, we did if you like, two options. One option that was a safe evolution of what some of the modular manufacturers, or the two modular manufacturers in this project already do. And then what we called option two, which we were more involved in and heavily involved and led the design of, which was more using more of our products to solve some of those problems. So, for example, the floor or the ceiling cassettes that we've designed to have no plasterboard in them. Very high fire performance, but no plasterboard. The reason being that there's waste involved in plasterboard. It's also quite timely to install. We've also, so I think what's really interesting is you have two completely different systems applied to the same common frame, making it, in my opinion, even more similar to some of those automotive sort of platform models. The other thing we've developed something called Trimmer Wall Fast Fit, which is I think it's a fantastic product. You literally use a bracket and rail system on a wall. You can put all of your electronics, your cables and your plumbing behind on the face of the wall, and you literally can just clip on panels to give you a fantastic finish inside. And we've actually, on this building, for the first time ever, we've used that on the external cladding for this building as well. All installed. In fact, some of the panels upstairs were installed by people like me. No, not even fitters. We don't. Completely reducing the level of skill required to do complicated things like, or high-skilled things like replacing people who would normally do plastering and paint finishing. We've reduced that and massively increased the time it takes with high quality to do some of these systems.
Yeah, and it's a different skill set, and I know there's a whole different debate to be had about skills in the construction sector and where that goes. The other interesting thing you were telling me earlier, Alex, was about the ability to almost pick this building up and move it and put it somewhere else. And I know that's a topic that the whole topic of reuse and recycling of buildings is becoming much more prevalent. And I guess being steel intensive, that whole recycling of a building, potentially the end of its life, is much easier as well, is it?
Well, the recycling of any steel building or component it's infinitely recyclable, but you've got to melt it down again, obviously, but you don't lose any quality in that recycling. What we're focusing on with this system is the reuse. The reuse not just of the components, but you could reuse a floor cassette, you could reuse a whole module, you could reuse the roof drop-on roof cassettes we developed here, and actually, there's two parts of this project that make the reuse likelihood of buildings like this SEISMIC demonstrator building, but buildings using the SEISMIC platform. One of those is that the system suits modular manufacturers, and it's an open platform, so you have many different modular manufacturers that can use it. And the other benefit is that it's a kit of parts approach, so you can break it all down, or they can come in and literally modular manufacturer or Tata Steel even can come and take the entire modules away, break them down, reuse the cassettes, reuse the components, reuse the whole system. And when we were looking at the project, when we were thinking about this, we actually did a survey of around 14, 15 different steel modular manufacturers and said, just out of interest, how often, when you've been given the opportunity to go back and buy back modules from buildings that you've built in the past, how often have you taken up that opportunity and done it? And every single one of them said, we have, and we always have, and we always will. Wow. So we employed Reuse, a company called Reuse Fully, some Gilly Hobbs and Catherine Adams, who are global experts in reuse likelihood and end-of-life scenarios, and they assessed that compared to a 5% likelihood of reuse of steel components from world steel on projects, the SEISMIC platform offers an 85 to 90% likelihood of reuse of the steel systems in this building, which is a tremendous environmental benefit.
So tell us, I'm tempted to talk to you all day about this because there's so many different aspects of it, Alex, I know, but how long has this project been ongoing so far? You talked about a couple of phases, and then maybe more importantly, where does it go next?
Okay, so we started this, the project was due to start start on April 2020. Funnily enough, we were very preoccupied with something else in April 2020. So we had a delayed start. We started in July instead in 2020. And we ran for, in the end, 21 months. And so this building was opened on the 21st of March 2022. And the project finished at the end of March 2022. So we've spent the last year obviously talking about the project, looking at business models for Tata Steel. How can we, as you rightly say, there's lots of different bites of this cherry. There's lots of different options, lots of different things for us to focus on. We've been looking at where's the best place for us to roll the channels, for example, for this. Where would we assemble floor cassettes, ceiling cassettes? How big is the market? You know, obviously lots of people talking to many different modular manufacturers. The other thing that's really interesting is we've been talking to, in fact, we've been approached by some of the largest consulting engineering companies in the country, because having a standardized system for modular manufacturers gives them the opportunity to design right at the front end, the start of a project, in the SEISMIC system, the SEISMIC platform, meaning that you don't have the situation where you design a whole project, the architect, the structural engineer, mechanical engineers all do their designs. They then decide to go down a modular route. It gets fully redesigned again, wasting all that time, wasting all that money. Instead, they can design it once in SEISMIC up front and then competitively tender it to main contractors, modular manufacturers, and us obviously playing a role in that to then deliver those buildings. So you're shrinking down all of that initial design, concept and sort of detailed design phase, and you're opening up a platform approach. And this is exactly what the government wants us to do. Driving a construction platform standardized approach doesn't limit the architectural aesthetics of a building. Just like the car manufacturers, what it does is it improves from the core, improves delivery.
Yeah, well, certainly from the outside, the aesthetics are unbelievable. But I guess, you talked about schools and hospitals as potential uses of this technology and system. But, when are we going to start seeing schools and hospitals using SEISMIC? So
schools already are. There's the Lawrence Culvert Academy is already being built by Algeco, formerly known as Elliott on the group, on the project. They're working on that at the moment. So that's the first full-scale project using the SEISMIC platform. Others are being worked on. It's being utilised, I believe, for various different, in fact, I know, for various different, I'll call fast food outlets, for example, and various different project types. So it is being utilised. Going forward, we've talked to the new hospitals programme. They've got to build 40 new hospitals in the next 7, 8, 9 years. Massive undertaking, an enormous undertaking. We've been talking to the Department for Education about how we can use SEISMIC or a variation of SEISMIC. We've been talking to, obviously, lots of modular manufacturers now really focused on really exciting projects coming out of the DIO, the MOD, so the Defence, looking at single living accommodation, about £5 billion being spent on those types of building over the next 5-10 years. So it might not be that SEISMIC, the system as it is, based on the span that it is exactly the right system for all of those. So we're working on perhaps a smaller span version that could suit this single living accommodation, hotels, and potentially residential, mid-rise, high-rise residential apartments, maybe even houses. So there's a lot of work to do, particularly with the hospitals program as well. Again, it might be a variation, but we're there and we're talking, we're involved in those conversations. And when it comes to building cassettes, whether it's for a school, it's for a hospital, it's for single living accommodation, we will design whatever we do to suit the slightly different variations that we'd need. But the process is the same. The standardization of the vast majority of the components would be the same. The way it fits together would be the same. Interfaces, products, quality.
Listen, this is really the cutting edge of construction technology. These modern methods of construction, off-site construction, the standardisations of the systems, the opportunities there. It's not just schools and hospitals, as Alex was saying. Anywhere you can think of where there's rooms or accommodation, this is a potential technology. We've talked a lot in recent years about the increasing value of collaboration between Tata Steel and academia and industry partners and government. And this is another classic example of that, where people coming together, get the best ideas, develop the market. It's better for the business, it's better for the environment, it's faster, it's cleaner. I mean, there just seems no downsides, Alex, and I'm so grateful for you for bringing us here today.
Pleasure. Fascinating
to hear about it, and I'll be really interested to see where it goes next, but thanks ever so much for bringing us here.
Thanks, Tim.
It is another fantastic story. Not this time about the specifics of decarbonising iron and steel making themselves, but the role of materials such as steel in reducing society's impact on the environment and the climate. I hope you enjoyed listening to Alex's story about SEISMIC and the role of steel as a material in driving not only net zero solutions, but truly sustainable life cycle solutions. If you haven't yet caught up with other episodes in this series, they're all available: Spotify, Google, Apple, wherever you get your podcasts. Do let us know what you think, or suggest other topics we can go and dig into. We'll be back with more stories about steel and the road to net zero very soon. Thanks for listening. See you next time.